Hi, everybody. I tried this time to, oh God, that's like an Inquisition light or something. I tried this time to actually have photos from the IETF and not from my backyard and stuff. So this is actually from Prague, which is a wonderful place if you haven't been. So this presentation covers two IETFs. So there was one in November in Bangkok and one a week ago in Prague. So if you're looking something up, just keep in mind that it might be, it's all intermixed, so it might be from a different IETF. And if you have any problems, just let me know and I'll be happy to steer you to whichever one, because it's all sort of melded together. Let's see. So a highlight, I found out sort of surreptitiously or serendipitously that .horse exists. Did you know that? Anyway, if you Google, you trace route to bad.horse sometime when you need to be entertained, it's pretty awesome and really funny. Somebody had clearly way too much time on their hands out there on the internet. The other thing I never talk about in these talks is there's this thing called Pechakucha that started at the IETF a few years ago. And they're really entertaining little presentations. They're sort of like bad attitude lightning talks. And I want to just send you a pointer to those, because if you need a laugh and you want to see IETFers making fun of IETFers, it's a really good time. And it happens late at night, and I'm usually too jet lagged to go, but I watch a lot of them online. Anyway, so those are highlights. Okay, so I started this a while ago because the chair of V6 Ops has challenged us to read a draft a week before the IETF. So I read a lot of drafts, and I don't talk about most of them, but a couple of them. This one pertains to this, God, that's a little puffy. This one pertains to this group. So it's all about sort of a survey of prefix lengths given to end sites. And the IETF has recognized that it's this community that really makes the decisions about prefix length and who can qualify for what. But they also wanted to put together some information about the percentages of different areas that use different prefixes. And I'm going to talk some more about this later, but apparently we have enough V6 for 102,400 years, which I think that math is probably a little bit suspect. But it's it's an interesting quote from the draft there, maths show, which is a good thing. Anyway, so that's a good draft to read. I read the SIP specification again. I read it about 1 million years ago, but they just republished it as historic, and it's really one of the first attempts at IPv6, like what was going to take over for IPv4, and it's kind of entertaining to read. And I read 464 XLAT because I really wanted to know what the acronym XLAT stood for, and I still don't know. But it's basically a way of V4 devices to connect over a completely V6 internet. It's basically like fancy NAT, multiple layers of NAT that you use. And it's used a lot in China, actually, because they do a lot of V6 only networking now. Okay, so the IEPG is this mysterious group that's met for 20 years the Sunday before IETF. And I just found a long-term IETFer on my way back from Prague who didn't know it existed. So there's a lot of people at the IETF that still don't know it exists, even though they've been attending. He wrote it down because he didn't want to forget. So it's a group of operators that meets. Maybe a few of you are here. I don't know, sometimes Rudiger's here. Anyway, it's pretty interesting. I wasn't at the IEPG meeting in Bangkok because our plane had a cracked windshield and we had to divert to San Francisco. So I missed it. So the IEPG part is all from Prague. So there's some work being done to measure QUIC. So QUIC is the new internet protocol that runs over UDP. So instead of TCP over IP, it's QUIC over UDP. And they're doing some measurements. Mostly this is used really heavily by Google, YouTube, a lot of the big content providers because it's faster. But apparently it's only faster if the packets arrive in order, and once the packets start being out of order, there are some problems. So there's some work being done to measure and figure out, like, is it really better? Is it not better? So there's a link to that information. There was some talk about using BGP to black hole DDoS attacks using BGP communities. There's a lot of work being done with that. And then trying to make sure that you can't maliciously use BGP communities to black hole traffic, because that's always an issue too. So that was a presentation at IEPG. So when a host gets disconnected from a network in V6 and it gets a new address via stateless auto configuration, it doesn't let go of its previous address, even though somebody else might have that address. So there's some problems. There's a lot of various V6 deployment problems, and this is one of them that's being documented, where you need to really be able to let go of the address that you just lost because somebody else might have it, and then you might not be able to talk to the person who has it because you think you have it. So this presentation was all about that. Okay, so the IETF is trying a new approach where they're trying to get all the stakeholders together for a particular part of the work that we do, in order to make it so that maybe we're not writing a standard that chip developers can't put in silicon, or various things like that. So the first one of these was this deep dive into router architecture, and they decided that the acronym stood for We Got Lego. I don't know, it's kind of weird. I don't understand how WGTLGO means We Got Lego, but anyway. So it was a really interesting afternoon talk about router architecture, and some of the quotes, well, assuming a zero gravity router is irrelevant, but I thought it was funny. But some of the realities are that, you know, the protocol designers are saying, well, we want a 128-bit whatever, and the hardware designers are saying, well, we can't do that, and there's this disconnect. And so like I said, some of these quotes are actually really the heart of the problem that we have. And so it was really cool to have all these people in the room, even though everybody was a little upset because, you know, the chip guys didn't want to do the 128-bit, and the routing guys are mad because the configs are humongous because they have to do everything in an access list. So it's kind of cool. I think they're probably going to do some more of these where, you know, we try to get everybody on the same page as to, you know, soup to nuts from how the policy affects the people actually writing the code and doing the hardware. Okay, so the key signing, key rollover, everybody knows about that, right? For DNSSEC, we rolled over the key. We got rid of the old key. So in Bangkok, we had a meeting. It was a preliminary meeting to just talk about, okay, we rolled the key. How often should we roll the key? Should we ever roll the key again? It was a real pain to roll the key, all that kind of stuff. So we had this, they had the afternoon on Friday, they had no meetings except for these side meetings, so I went to this one. And so these are all the questions that came out of that, like I said, should we roll the key? Should we roll it regularly? Should we never roll it? They're still really trying to work that out. And then that rolled into this futures BOF that happened in Prague just a week ago, which was a follow-on of the same process. So now that we've not only rolled the key, but we made the old one invalid, you know, what happened and what was the fallout. And there were some people who talked about how there were 250 million users adversely affected, but nobody really knows because the DNS is so dense and opaque, and it's really hard to measure. And maybe a lot of places just turned DNSSEC validation off and left it off so they didn't have a problem. So really trying to grapple with how do you measure these things and figure out what happens when you roll the key and what really is broken. So there's a lot of work being done on that. I'm not sure if there are any really good answers at this point. Do you have something? No. Okay. So DHC, dynamic host configuration, and this is the little bit from the charter. All of these at the beginning have a little bit from the charter so that you can know like what the group's about. But basically, this is DHCP in all of its forms, and automatically configuring host addresses. It was started in 1989. It's the longest running working group, and we're hoping that after November, when DHCP v6 becomes an full internet standard, maybe the working group will go away, but that's where we're at with that. So it's, again, DHCP v6 isn't actually a full internet standard yet, it's just a draft standard. So one of the things DHC is working on is there's so many devices on the internet that are short-lived, or they're Internet of Things, little gizmos in your house, and they don't really want to hard code MAC addresses into those devices because, of course, just like IP addresses, MAC addresses are a finite resource. So, stranding a bunch of MAC addresses and little gizmos that you threw out the year before is probably not the best thing. So they're working on this whole link layer, being able to assign MAC addresses with DHCP instead of having them hard-coded in the hardware. So, and half of the MAC address space was split into this local amount of address space, and it's broken into these quadrants. And so part of the protocol that's being worked on is, how do you tell the hypervisor board that it's this quadrant and then give out the MAC addresses to the little devices. So that's some work going on there. So link state routing, I started following just because I think that the data center, link state routing in a data center is something that I thought was interesting to follow because you have these really dense data center networks and link state protocols are really chatty. So there's a lot of work being done. Almost kind of too much work being done, like a whole bunch of protocols trying to solve the same problem, just like we had with all the tunneling protocols from to get V4 and V6 working. Now we have a whole bunch of protocols to make data centers less chatty. So that's mostly what these slides are about. There's a bunch of different modifications to the protocols so that there's less flooding and so that your data center doesn't melt down when things move around. Let's see, this is another algorithm for limiting the flooding. There's another hierarchy to ISIS that's being proposed to limit the amount of chattiness in your link state protocol. So that's mostly what's going on in that group. DNS operations is, of course, all about the operations of the DNS system, everything that could go wrong, and more about the key signing key we talk about in there, that sort of stuff. This draft we've talked about before basically lets resolvers downstream from the root be able to serve stale data in case the servers up above are being DDoSed. And that really makes a lot more resilience in the DNS if you can at least use the information you have, even if it's timed out when you can't get new information. Let's see. This is a new record type in the DNS that functions in ostensibly like CNAME does, but it gives you, CNAME has a bunch of limitations and can't exist with certain other resource types, so it's a way of updating the CNAME functionality so that it's more useful for a bunch of different features that people are trying to do. Let's see. This is a way of locating, okay, so for a while we were trying to put everything in BGP, like adding more and more stuff, and now they keep adding more and more stuff to DNS. So this is adding different services that you could find, but adding it to the DNS. So like you could find your blockchain in the DNS, and you could find various other infrastructure and people and stuff in the DNS. I'm not sure how far that'll go, but we'll see. And these are some other drafts that I'm not going to talk about, but that are going on in V6 Ops. So they stopped having the technical plenary, but I always go to the plenary, and this time it was all a bunch of record keeping and this and that, but this slide I just think is hilarious. So basically this is a sign on a building that basically says nothing ever happened here, and hopefully nothing will ever happen here in the future. I just think it's funny, sorry. Little levity. Okay, so computing, and then so there's the IETF and the IRTF. The IRTF is a research forum that works in parallel with the IETF and does things that maybe the IETF isn't quite ready for. And occasionally, well, I go to the IRTF working groups to see more like futuristically what's coming down the road. And this research group is all about moving computing as close to the end as possible. So out in the network, having your switch do things that are closer to you. And the concept is the edge is constantly changing. The edge of the network isn't really the data center anymore. It might be your neighborhood, or it might be various community groups or whatever. And so, for example, in industrial networks, you know, that second that you're talking to the thing that's welding the part, maybe you really want it to only be a second delay and not a 20-second delay to go up to some data center. So they're working on ways to push computing closer and closer to the actual thing that's moving that you're trying to make work out on the network. Yeah, like I said, neighborhood clouds is another computing concept that they're working on. Like maybe things happen more. I mean, we already do this, right? Your little cable modem at home does your DNS for you, and it does your NAT for you, and it does little bits of computing that you don't have to go all the way up to your ISP to do. And this is sort of more of that. And I'm not sure that like a lot of those little devices and routers and stuff will be able to do any of this computing, but it's a really interesting thing to think about. Okay, so operations security is exactly what it means. It's all about security out on the network and securing the network. So this is a draft that started quite some time ago, and it's almost ready to be published. So if you're interested, you should check it out. We asked that they remove references to PI address space and some things that affect this community because they really have nothing to do with security. They have a lot to do with whether you can move your stuff from one ISP to another, but that's not really a security issue. So they're cleaning up some of those things, and then this should go out for last call pretty soon. Since 2012, I think it might be time. And in V6 operations, so there's V6 operations is just, it's all about operating a V6 network and the interaction between V6 networks and V4 networks. And I'll talk about the partner to this group in a little bit, but that's what V6 Ops is. So anything that we need to make V4 and V6 work, or to make V6 work operationally, is what this group does. Let's see. This is getting your NAT64 prefix from your router. So when you're just a V4 only host, you need to get an address to get on a V6 only network, and this is a protocol to allow that easier than it is now. This was a real life, they do a lot of V6 in China, and this is a survey of CERNET2, which is a big network, education and research network in China, and they're not at all dual stack. So they do V6 natively, and then they translate on the edges, and they're working on ways to make it so that they're not doing multiple V4 to V6 to V4 to V6. They're just doing one translation and then going to the other end and then untranslating. Oh, sorry, shouldn't gesture. So, yeah. Let's see. Yeah, so this is a deployment guidelines if you're gonna do translation. So like if you have a V6 only network and you still need your V4 stuff to talk to the rest of the internet, there are operational considerations that you should check out that might help you in deploying. And then the partner one to this is a comparison of all the transition mechanisms so that you could use if you have a V6 only network and you want to make sure all your V4 hosts will work. And a lot of these are being used. There's been talks I've given before, different organizations that are using MAP-E or MAP-T, and this is basically a comparison of all the different mechanisms. Yeah, so again, this is more translation information for CDNs. And so the IRTF, like I said, is the research forum, and there's a contest every year of papers that are like, they win the research award, Advanced Networking Research Prize. And some of these are really great. They're really, I always try to go to this because the papers are really interesting. This is all about, Facebook built this, they call it Edge Fabric. Basically, it's a real fancy, I'd call it maybe a route server that takes a whole bunch of notice of the, the speed and the bandwidth and the congestion on the different paths, and then routes the outbound traffic based on, different criteria. And they've had some really good results. I worked at a company that did something similar like in 2002, and it can be really helpful, especially in their case because all of their customers are just sucking down a lot of data. If it was the other way, so they're optimizing the traffic from their customer to them, from them to their customer, sorry, because that's the most of the bandwidth goes that way. So this was a really interesting talk. And then this is all about BGP communities and how far they propagate in the network. And I took out the slide. There was a little bit of a talk about this in IEPG as well. I only have 60 slides this time because I tried to get rid of as much duplication as I could. But BGP communities are used a lot, and they go really a lot further than in the network than people think, and it's kind of a little bit scary. So that was cool. Let's see. And then they also talked about QUIC, again, that new protocol, and just how does it work with compared to TCP, and does QUIC on the network affect TCP performance? So there's a ton of work being done now that it's being used so widely, fairly widely. There's a lot of implementation. So this was about that. And then I went to this group, MapRG. It's basically measuring different protocols. And I think they talked about QUIC too, but I took it out. So there's privacy and security in V6 networks. That was a talk that they had. And again, more QUIC performance over satellite this time. And some other measurements that they're talking about in the group. So HomeNet, I'm probably gonna phase out going to HomeNet because they're kind of as far as they're gonna get for a while, and they're starting to do marketing slides of how they get more people to do HomeNet, which is kind of, so yeah. And there's some, I think that we really have, because a lot of the V6 networks are dual stack with V4, we have a few problems because of that, but it hides a lot of things. And a lot of these, they're starting to do these home networks that are V6 only, and there's a lot of little problems like, how do we secure it? How do we send keys around? What do we do when there's nothing there to configure it? So they're starting to look at like having a code on a device, like a barcode that you scan, and then the network knows, oh, that's a legitimate gizmo that you're plugging into your network, and it does whatever, and this is how you configure it. So they're, it's just hard to try to standardize something that there's no one physically there to configure. So I don't know. But again, how do keys and credentials for different things that get sent into a home net? How do you get your naming? All that stuff is still being worked on, and they're not easy problems to solve. Okay, so like I said, V6 Ops is all about V6 and V4 interacting in the network and making sure that it works. And V6 Man is all about fixes to just V6 protocols. So the real protocol work happens in 6-man. So they're putting out a node requirement draft. I think I've talked about that for a few times that I've done this presentation. And the segment routing header, I'm going to have a little rant about headers in a little bit. They're starting to finally finalize those. Let's see. Yeah, so if you're a V4 only host and you connect to a V6 only network, this is a way that the network can tell you don't sit around and wait and wait and wait for the timeout to get your V4 address, because you're never going to get a V4 address. Just go and use V6 already, because that's all there is. So this is something that those V6 only networks have really experienced. Like a V4 only host takes forever, like a host that starts out as V4 takes forever to come up and use V6 because it has to time out. And it shouldn't have to. If you're only V6, you should just use V6. Let's see. Okay, so my little rant about headers. We were having a discussion, some of you guys, we were having a discussion about MTU, minimum packet size on the network, and how it's really out of date because it's an IEEE standard and Ethernet is 1,500 bytes. And these, with V6 and all the headers and all this stuff, the packets are huge. And the network, there's still no good way to discover, what the minimum packet size what the maximum packet size you can send without it getting fragmented and not working. And so there are two different options being worked on in 6-man. One is this hop by hop option, where you discover your MTU at a hop by hop, and then there's a packet too big message thing that happens, and I think I skipped it. I think it's this slide. Yeah, no. Oh, I'll get to the other one. So there's quite a bit of work being done on that because, in reality, packet size should be like 9,000 bytes. And as the links get fatter and fatter, you want bigger and bigger packets so that you can more effectively fill the link. So we have to figure this out at some point. And as we add more and more headers and we do more and more tunneling and all those sorts of things, the packets just get bigger and bigger. Let's see. So this was a big discussion about how to generate these kinds of stateless address auto configuration and how to get your, I guess I already talked about your NAT64 prefix from your router advertisement. A lot of this stuff gets presented in multiple groups. So I try to filter it out. So this is a segment routing header, another thing that's going to make the packet even bigger, and it's almost going to last call. And there's several implementations now, so it's probably going to happen. And again, now this is the other MTU discovery mechanism, which is a packet too big message that gets sent back. And the truncate bit's set, and then it's that you have to send a smaller packet. And these are some other drafts that are going on in 6-man, another MTU draft, and some various other things. So global routing operations, I go to this occasionally because I like to see kind of what's going on out there in the operator world of routing out on the internet. Let's see. So like I said, from that other paper, there's a little crossover here. There's communities everywhere. They propagate really far. And there's a lot of ways to hack that and black hole traffic that are really big concerns for the operator community. And they're starting to work on ways to prevent those sorts of hijacks. Let's see, this one. Yeah, using BGP measurement protocol to make sure that your prefixes go where you want them to go is what this one was about. Since we haven't really rolled out BGP security and on a really big level yet, so they're trying to detect route leaks without the humongous access lists. So this group is new, and I just wanted to point out that it exists, and it's basically about securing all those little Internet of Things devices in your home and keeping them from being bots and spreading porn and whatever they do. And so they're just starting to form like an architecture and an information model and some various things, and they do a hackathon before the IETF, and they're starting to do a hackathon of the securing of the Internet of Things. So it was just a little, I go to, when there's no IPv6 something going on, I go to some other group, and this was some afternoon session that I sat in on. So for those of you who aren't friends with me on Facebook, you missed my awesome live streaming from the IETF on my Facebook wall, where I go on and on about what is the quantum internet anyway. And one of my friends on Facebook, of course, is in charge of the research group. So she made a tutorial just for me. So I'm supposed to know now what the quantum internet is, but I'm still baffled. So there's some of my notes from the quantum internet research group. I really do keep pondering, what is it anyway? Maybe if you're a physicist and you talk really slow, you can help me. I don't know. But, so they did have a tutorial in Prague on what is the quantum internet. And to me right now, the quantum internet is massive distributed computing where you're, connecting a bunch of different research facilities over the internet. But I do understand that in the future, we'll be sending around things that never occurred to us that we would be sending around on the network, I guess, maybe. So I did a big road trip recently, and I listened to a lot of NPR on my road trips. And I don't know, you guys probably all remember, people in this room saying that with V6 it can address every grain of sand on the planet. And I always joke that that's all fine and good, but if you give it away a beach at a time, it goes away really fast. So I was driving back from California, and there was a NPR, it's so perfect for the Caribbean, there was an NPR thing on the radio about how in Jamaica there's this beautiful white sand beach in the middle of the night. They came with helicopters and bulldozers and they just took the beach away. And there's this whole sleuthing thing going on trying to find where the beach went and who stole it. They haven't solved that yet. But it got me thinking, it woke me up in the middle of the night because we're actually using sand faster than the planet can make more sand. And when you take sand and you make it into concrete or whatever, you can't get that back and readdress it and use it again. And I just thought it was sort of a metaphor for V6. We want to be, we might be addressing things that we never thought of. We might be using it to make things we never thought of. And to say that we have 102,000 years worth is probably not realistic. And so I don't know, I just thought it was hilarious. So if somebody's from Jamaica and you know where the beach went, they're thinking that the resorts on the other side of the island stole the beach, but they mix it in, and so the forensics guys can't tell whether it's the white sand from the other side of the island. Anyway, it just made me think about V6 and how we think we have an infinite amount, like you'd think we have an infinite amount of sand, but we don't. So anyway, onward. It's your thought for the day. All of these, the data tracker and all these things are really good references if you want to go check out the IETF. And if you're going to go to the IETF, please talk to me. I'm happy to help, be your mentor or whatever. And there's also some good information online about how to attend an IETF and not be offended by the geeks and all that sort of stuff. So I've been to Prague 4 times, and I didn't ever really realize that the Grand Ballroom has this awesome mirror in it. So this is actually an IETF working group and guys standing at the microphone to ask questions. I just thought it was awesome. I perched in the corner. Anyway, questions, comments? If you were there and I got something vastly wrong or whatever.
Go ahead, Kevin.
Kevin Bloomberg, The Wire. So today's a special day, Kathy.
It is?
It is. It's the 50th anniversary of the RFC.
Oh,
RFC
yeah.
won 50 years ago today.
Woo!
No, April 8th.
Written by?
Okay. Steve Crocker,
I know.
Dr. Crocker. Whether it's the 7th or the 8th, I will defer. But
It's close enough.
Close enough. So to another 50 years with all of us in the room.
I know, right?
Michael Casadevall, Noralo. This might be a slightly touchy subject, but has there been any discussions on possibly opening up the last remaining blocks of IPv4, the Class E space, for future transition 5 to 10 years down the line?
No, because well, there have been discussions, but the thing is that the amount of time it would buy us pitched against the amount of engineering and host changes it would take, it's just not worth it. I mean, that's basically, does John have a?
What Kathy said, we discussed that even for private space 10 years ago, and it got no traction because too much effort.
Right. There's been at least 2 internet drafts that talk about that were discussed in the IETF, that both of which were panned by that community.
Yeah.
There have been drafts suggesting that to the IETF. Both were panned in the IETF community.
Yeah.
Okay, thank you for that answer.
10 years ago, that was
Anybody else? Or was that just everybody to the microphone? All right, well, thanks, everybody.
Okay, thank you.